There we are. It's top of the hour. And something just made a noise on my end, so that means I think we can start. So yeah, glad you're with us. And then I've just stopped that noise for the next 45 minutes. We're going to talk about how to monitor storage systems, whatever the vendor. We'll be looking at native and custom sensors and how to build a single pane of glass view for maximum visibility and control. And yes, my name's Natalie. I am your host for today. And just very briefly, as always, we're going to go through some housekeeping with you. So if you move on to the next slide, we are all muted right now, apart from obviously the speakers. So your cameras are off and you're muted, but it doesn't mean we don't want to hear from you. So you have access to the emojis, hopefully, which you can see at the bottom of your screen, and you can use those to react to the things we say. There you go, it works. And you can obviously use the Q&A feature here to ask your questions. And we do have Jasmine and Burke in the background helping us to answer some of those. So you should get some of the answers as we go. And we may also allow some time at the end to answer some of those live. We'll see how we go. We are going to be running a poll later. And in fact, I'd like to run a quick one right now. Let's just test how it's working. So Melly, if you could put the first poll on, please. I'd like to know if this is your first ever Paessler webinar. So are you new to these webinars? And I'd also like to understand how often you could commit to joining webinars like this. I mean, we all have busy schedules, but how often do you think you could make it along to these sessions? This is just helpful for us with our planning as well. And I can see there's quite a few first timers here today. Welcome. And we have different series. I'm not sure if you're familiar, but we do have this Monitoring Matters series, which is more of a hands-on live demo session. But we also have an Inside PRTG series, which is where we talk about more about the product and the releases and all of the good stuff that we're bringing to you guys. So I can see that some of you have been to that one as well. Good. Then I think we can, yeah, thank you. We can stop sharing, and I think, are we showing the results, Millie? I don't know if we are. But anyway, we have that data, so that's very helpful. Thank you very much for responding. So I'm going to stop talking now. This presentation, just so you know, is going to be recorded. We'll send you the presentation slides, so don't worry if you miss anything. You will get that in an email, I think probably tomorrow. But I'm going to hand over to the experts. You can see them on the screen, Marco and Michael. So they work with customers like you every day, and they really know how to get the best out of PRTG. So I'll leave it over to them, and I'll appear again when it's time for the next poll. All right, I'm going to disappear and leave you guys to it. Bye.
Thank you, Natalie. Yeah, my name is Michael Schlosser. Hi, I am pre-sales consultant here at Paessler, and today I walk you through the presentation part, while my colleague Marco will take over for the live demos later on. So the agenda for today, we will discuss about common situations that you might, or that might sound familiar to you as well. We talk about from complexity to clarity, like we look into the challenge of monitoring diverse storage systems and how PRTG helps to simplify with that. The main part will be multi-vendor monitoring. Here we're diving into how PRTG supports different storage vendors in a unified way. And from data to insight, we'll check about how to turn raw metrics into actionable information. Well, then we will do a quick wrap-up, and if time permits, we'll open the floor for a short Q&A session as well. So let's start with common scenarios here. So here are 3 different scenarios you might find yourself. First is the uptime only dashboard. So let's say the administrator points PRTG at the storage arrays, but only adds like a ping sensor. So every morning they have a glance at the green dashboard and just move on. So everything looks fine, but yet there's no tracking of IOPS, capacity trends, or anything else behind the scenes. In the second one, let's say auto discovery was run at the beginning after the installation or after new storage array has been added. And it adds just basic disk sensors. And that is enough to see use space, for example, but not much more than that. So there's no insights into latency, rate health, replication, and so on. So all those issues stay hidden until users start complaining. It actually feels like monitoring, but it's really just a surface visibility, so to say. The third one, the one-time setup. So here the IT team maybe installs PRTG and runs the auto discovery once, but then never revisits the setup. So a month later, the system still hums along, but no thresholds or reports or custom sensors were ever touched and configured. So PRTG works quietly, but IOPS spikes or slow snapshots still go unnoticed. And that's actually how we see many environments. And many environments look like this today. So PRTG is installed and collecting data, but often only like basic sensors, for example, ping or CPU disk space, traffic, and so on. So it's already quite helpful. It shows you some metrics. It gives you the uptime of the system. But there's so much more untapped potential beyond that. Especially when we're talking about storage performance and health monitoring. So today we focus on multi-vendor storage systems, whether they are on-prem, in the cloud, or hybrid. Regardless of the vendors, most devices actually speak a common monitoring language. May it be SNMP or REST APIs, WMI, SSH, and others. And this is what makes PRTG so effective. It unifies all those different sources under one single platform. And with this, it's poll time, and I'm giving back to you, Natalie.
I'm coming. Sorry, that came around quickly. So yes, we would like to understand from you. And Melly is in the background. She's the one who's looking after all of this, by the way, and launching the poll now. You should see it up here on your screen. So which storage vendors are part of your environment today? Maybe you can choose from the list there, and we'll share the results after just to see what is most used. And I'm sure we have our guesses. Maybe we should place our bets now, which is going to be top of the list. We'll give you a little bit more time to answer. You can see the bars are still moving, so you're still participating. Yeah. Any more last minute clicks? I'm going to give you 5, 4, 3, 2, 1. All right, Melly, should we share? Let's share those results now. So you should be able to see those on your screen. Everyone, looks like Dell is top. Am I right? And then Synology and Azure. Those are the top 3. Hopefully that lines up with what we're talking about today. I'll hand back over to you now, Marco. Thank you, everyone.
Thank you very much. Yeah, we have Dell, HP, and NetApp in the tops. So it's good. We will cover them in detail today as well. Let's see. Our goal today is quite simple. We want to help you to expand your monitoring and get full visibility into your storage environment. So by the end of this session, I want you to feel inspired to use PRTG's wide range of sensor types to build a truly comprehensive view. So not just what's easy to discover, but what really matters. And with this, we come to our second chapter here, from complexity to clarity. So let's start with the fact that storage environments today are rarely homogeneous. So most organizations run a mix, and they consist, among others, out of Dell and NetApp, HP, Synology, yeah, and many others. So each come with their own tools, interfaces, and performance metrics. And That fragmentation means admins spend often more time checking than actually monitoring. So they have to juggle between multiple dashboards, log into several systems, and often notice problems only when users start complaining. On top of that, data volumes keep growing while teams are expected to react faster, and that often with fewer resources. The result, blind spots, slower response times, and a higher risk of downtime. So the challenge isn't just monitoring storage, it's creating unified visibility, and that across a fragmented landscape. So why does unified monitoring actually matter? The simple answer here is speed, clarity, and control. And with a single dashboard, so-called single pane of glass, you can see your entire storage landscape at a glance. And that means you troubleshoot faster, you react to alerts immediately, and you avoid waiting for users to report problems. The standardized KPIs and alerts across vendors, they remove inconsistencies. So everyone is looking at the same health metrics, and that whether it's a Dell, NetApp, or a Synology. And most importantly, this allows proactive monitoring. And instead of firefighting, you catch capacity issues before bottlenecks or failing disks, etc., start to impact applications. That, of course, directly supports business continuity and also keep your SLAs intact. So now that we know why unified monitoring matters, let's look at the key KPIs that every storage admin should watch. So once we've unified visibility, the next step is knowing what to measure. Every vendor provides dozens of different metrics, but we listed 6 different categories here that really matters across all environments. And first of those is capacity and utilization. Here it's about understanding not just how much space you have left, but how fast you're also consuming it. Then we have I/O performance, like latency and throughput trends. They help to spot bottlenecks, and that long before user notice a slow application. Rate and disk health, also very crucial. So one failing drive in a large array can widely degrade redundancy if you're not carefully watching it. The next one is temperature and environmental health. So that is quite simple, but also often overlooked. And in fact, overheating drives are still one of the top failure causes. And of course, we have snapshot and replication state. All of those ensure that your data protection and redundancy mechanisms are actually working. Finally, error and alert status. This is your early warning system for any issues the storage array itself detects and reports. So whether it's failing disks, a power supply, degraded controller, it gives you immediate view of your overall system health. And those key KPIs, those KPIs form basically the baseline for consistent monitoring. So regardless of vendors and protocols. Later we see how PRTG capture each of them through either native sensors based on protocols like SNMP and REST, and also some of our custom sensors. Let's go on with our main part, the multi-vendor monitoring. So now that we understand the challenge and also the key KPIs, let's see how PRTG solves it. PRTG offers one unified platform for all your storage monitoring needs. So you don't need separated tools for each vendor. So whether it's a Dell EMC, a NetApp, HP, Synology, QNAP, Buffalo, or even cloud storage. PRTG can monitor it all. It supports multiple protocols. I mentioned those before. They are like, for example, SNMP or different REST APIs, WMI, SSH, and so on. So you can always pick the best method and protocol for each system. Pre-built vendor-specific sensors in PRTG make setup very fast, and our auto discovery feature ensure that nothing is missed. Then everything comes together in flexible dashboards, giving you a single view of your entire storage environment. And with the with centralized alerts and thresholds, which you can configure, you are notified of potential issues before they turn into downtime. And for unique cases, custom sensors like SNMP custom or to monitor even the newest or unsupported devices. So let's start with NetApp and Lenovo EMC. They are both mid-range or very common mid-range monitoring, storage systems. And some of the key KPIs here are IOPS, latency, capacity per volume, and also snapshot and replication status. These tell you immediately if performance is dropping or data protection is lacking. And PRTG includes native sensors like, among others, the NetApp I/O, the system health, and a Snap Mirror, as well as Lenovo EMC physical disk and system health sensors. So setup is very straightforward and consistent. With these in place, you can spot issues early, such as replication delays, capacity bottlenecks, etc., before they start to impact your apps. So that being said, let's jump into our first demo and show some of those live. I'm giving over to you, Marco.
Thank you very much, Michael. That one, I'm just taking control right now. Sharing my screen to you. And I've been just jumping now into a PRTG installation. And as you can see, everything that I'm displaying to you right now is our group storage. So there are the different storage vendors we have in this environment just to display them. And we've specifically chosen a few of those to tell you about today, about special vendors, about special sensors we're working with at this point, to also give you an overview of what you can be doing and how this could look in the real world. So as you can see, it doesn't really matter which vendor we take as a first one, because we've got a wide variety already available. For this one, we just start with some of the ones we've seen in the poll, which is for the first one, just a quick look at the NetApp. For the NetApp, it's very, very easy because a lot of the things we're doing are SNMP based, and we've predefined some of the sensors that are already available for the metrics that Michael has mentioned at this very point. If we just jump into this, you can see that we have a wide variety of sensors that are already running, that we are already able to look at, just to get a quick overview of what is really available in the system. We're talking about different things, like, for example, enclosure things. We're talking about disk settings. We're talking about network interfaces. Within these network interfaces, we can also jump into the logical interfaces, so we don't have to work just based on the physical availability, but also on the product's availability, which would be logical interfaces behind it, the aggregates we have in there, and the system. To see what metrics are in there, I've just quickly jumped into some of them as the first basis, because this is what's the most important one we need. We've got a system health for the first overview, which means we have a full-on system health for this one system that is available in this NetApp cluster. We can see what PSUs are doing, what's the battery doing, how many spare disks are available, is the spare size usable or not. So we've got a direct overview over everything that's available in the NetApp system. That's already telling you what we're doing here about it. So it keeps you up to date for everything that's in the status size. Now we just need to expand on these informations Because just having a system health is nice to see, but it's not all the information we need. Michael mentioned that there are much more metrics we have, and those metrics can also be gathered. There's a sensor just for the disk free. That's a pre-built sensor we have available to you, so you can monitor every single disk you have in the system, be it an aggregate disk, be it a normal disk we have in the system, just to see values like the free space values, the disk status. So is it mounted? Is it not mounted? Do we have a problem? Is everything running free? How many bytes are free? What's with the deduplication? So all those values you need to really determine if this disk is still something you would want to use, or maybe you need to add some disks, or that's you just move the next ones to the next disk. Different thing, like for example, the enclosure. Here we are also monitoring in the voltage department, so we can see, are there fluctuations in there? Is everything running normal? Is it in a normal pattern? Is it in a normal environment? For things like these, we also always recommend having a look at the history. See if there are big gaps, if there are jumps in there. See what happens with the systems. How does this develop over time? Also things you should be looking at. Same goes for temperature-wise. We are using every single temperature sensor that's already built into the system itself. So we're not developing new things. We are just using it, putting it into a straight-on overview and having a full view of what the system is doing. As Michael already told you, it's very important to keep track of your temperatures. This also means that you are allowed and able to use thresholds, limits inside of every single temperature sensor. These are the ones we are offering at the very beginning to see how does this develop. Is it getting hot? Is it getting too hot at this very point? And maybe you're able that with these information to react before something critical happens. You can save the devices inside of this very much with just this information. And putting this into perspective, for the enclosure, we can also jump towards the fans. The fans are the possibility then to maybe see why is the temperature rising. Are the fans not running quick enough? Do we have fans that have failed? All this as an information pattern in combination with the system health itself can lead to you not having to run after the parts you need, but be able to really work ahead of the time, to really work ahead of schedule. You can just not only see the problem, you can use the information you have in the system and define your own path around the problem. See whether it's a fan-based problem or it's just a temperature-based problem that could lead from a broken disk inside of it that's just running hot. It doesn't matter what the problem is, you can check with PRTG directly in one system where the problem lies, what is indicating this problem, and how could you react from this one. Things like enclosure in the currents, also for the disks, are very much the important parts there that you can see how is that developing in the future. Same goes for things like, example, the lifts at this very point, which are the logical interfaces we have in the background. We're not just monitoring physical interfaces. So if you're not using just the physical interfaces, you can also just jump at top of them, use what is called the lift inside of the system, which gives you an overview of every single thing that you're running through this virtual interface. So also something you should keep your head about. And of course, we've got a physical disk sensor that would enable you to not only monitor the capabilities and the capacities of the system, but also just take a look at the physical disk that is actually there. See how much is in there, see how much IOPS are used, how the latency is. Is it a container type that is shared? Is it an aggregate volume? Whatever kind of volume this is, or does it have a problem? Those are also predefined. You can ship the throughput. You can set limits towards the throughput. Be on the lookout for every single problem you find in there. So you can define it your own way at every single point. Same goes in these regards for the snap mirror. We're also using displays. This is a predefined sensor. You can use this one right from the get-go. Using snap mirror, you can use this sensor, get your own information out of it, see how long it takes the transfer, how old was the latest transfer, watch the mirror state. Everything in here is predefined for you, and helps you enable and scale the monitoring, especially in these regards towards what you need from the system itself. And to round this really much up at the very back, to get even more information about this, you could jump into the I/O side of things. Also predefined as a direct sensor, which gives us information like SCSI infos, CIFS information, FCP. Whatever you need at that very point is up to you. We're not providing direct breakpoints here or thresholds. You're allowed to set your own. So whatever you're doing with this machine at this very point, you can define for yourself, where should I land, where should I be, and how much is the capabilities of the system. In an overview of everything we have, especially for a NetApp, you can gather up very, very much information. You can really spread this out and have everything in a direct overview, just to really look at what the problem is, where the problems are coming from. You can also size this down. For example, for Lenovo, this could be something like the bare minimum configuration you should be running. Same one here, you've got a ping, you find the system health where you can see what's the rate status, how's the fans working, what's the temperature in the system. If this is a smaller system, I don't need to dive into real depths in there. Maybe I just need the system health, and maybe I just want to know how are the disks doing. Are the disks fine or are the disks not fine? There's always another possibility in the system itself, but you should never lose sight of everything that's in your system at this very point. And with these informations for Lenovo and NetApp, Michael, back to you.
Thank you so much, Marco. Very cool. Let me take over again. Okay, so okay, next in the list, we have Dell EMC, EqualLogic, and Unity systems, as well as HP 3PAR. So the most important metrics here are system health, disk status, capacity per LAN, and IOPS and latency. They are all crucial to keep applications running smoothly. PRTG provides, among others, those pre-built sensors listed here. For EqualLogic, we use, for example, the member health and a logical disk sensor. For HP 3PAR, we have the drive enclosure and common provisioning group sensors. With these sensors, you can identify failing disks, you catch degraded RAID sets early, and also spot I/O bottlenecks, and that before they affect workloads. Monitoring pool utilization also helps to plan capacity expansions in a proactive way. Now let's switch over again to another live demo and have a look at EqualLogic volume performance and HP 3PAR pool health in action.
Once again, thank you very much, Michael. With this, we're also jumping over here. And as you can see, I just jumped into the Dell EqualLogic system at that point. The Dell EqualLogic we have right here is just part of a bigger member. So we're also just monitoring the baseline parts we want to see at this very point. Once again, we're starting off very simple. Just check the availability, check that it's responsive at all, have the most important information right at the top. And then you are once again down to deciding. For example, for the Dell EqualLogics, we're starting off with the logical disks right here, just to get an overview of everything that's in there. The very most important part on every single one of these checks here is that the availability is there. Right from the get-go, the check has to be if it's available, if we can write on it, and if it's really doing what it's supposed to do. Once again, you can see the first availability is just there, but it's also into the operation status, which does not just mean that it's available, but we also know, is it available to the extent that we want it to be extended to? We've got different status information already in the system, so we can check if it's not just available, but if it's accepting connections at this very point. All these informations are already pre-built into the system, and we are just there to give you the information that would otherwise be on the system itself. So that's why you don't have to look for it through every single volume. As I told you, things like the average availabilities, average write latencies, the connections you get, they are being checked for every single volume you have in the system. Doesn't matter which group it is, which configuration is set in it, and which values it should be returning. We have it all in a single sense. Those things like the availabilities, the operation status that we have, are one of the more complex and more important things that are already in the system itself. There we also give you direct limits, which is availability yes or availability no, or as you have seen in the operation status, things like available but no connections are allowed. That will lead to you having to check why there is no allowed connections anymore. Otherwise, things like how many connections are in there. What's the average times for read? What's the average time for write? What latency do we have in there? Things like these are also prepared, but not limited. Once again, this comes down to what have you configured in this. It's your choice, especially in logical disks, how much possibilities are there. So you can define to your own liking, to your own support, how much you want in any of these cases at this very time. The equal logic is open, the sensors are there, we've pre-built them, and you can start with them. You can also go for the simple physical disks overview. Also here, since it's just physical disk, we've got an overview of everything we have in there. Is it normal setting? Is it a spare setting? Is it working? Is it not working? What type of status do we get? Do we get a healthy status? Do we have an unhealthy status? Is it encrypted? Is it not encrypted? Things like these help you define exactly what the physical disk at this very moment is doing. Once again, without having to check directly in the system what you're having on top of all of this. And very important, once again, we've got a full-on member status. So every single equal logic member we have in here gets its own status. So you can define, once again, if you have 3, 4 members, or in this case, 2 members that are in there, set up the member status, and then you can check first off for the raw member status, online, offline, but also for the full-on status, like the rate status that is in there, its own health status, the cooling power that is used, how much or how many spares do you have in the system? Is the temperature fine? We are also taking as much temperature data out of this system as there is available. So if it's a small one, it's just a few, but if it's a large one, it's a big system set up there, we can get more and more data. So this scales with the development you have in your own environment. Things like latencies, once again, average here, not per disk, but per member in there. So you can really see and break down what the system is doing. Other things like, for example, storage, it's up to you. It's your decision how much you want. Once again, you're calculating your own storage. So you need to see how much of this storage should be free at all times and how much should be moved and how much should be gathered at that very point. And as I already said, this is set up per member of this group. So in this case, we have a second one, and we gather up the same data once again, just completely individual from this equal logic system at all. All this information, once again, pre-built sensors from PRTG, they are already there. You just have to roll them out and convert to your own liking what you want to see and where you want your limits to be. And with that, Michael.
All right, thank you so much. Then we have a look at the next set, which is the Synology, QNAP, and Buffalo. So here we're talking about NAS devices, very common in SMB and branch office environments. The key metrics here are volume usage, disk health, rate state, temperature, and also network throughput, since they are network attached. These show both storage performance and device health under normal and sustained load. So PRTG provides native sensors again for these devices, like the system health, logic disk, physical disk, and also traffic sensors. For Buffalo or other NAS devices, we also have generic SNMP sensors to cover the same or similar metrics. So with this setup, you can detect failed or rebuilt disks, you can monitor bandwidth utilization, and also check device temperature. So all before it starts to impact users. With that overview, once again, time to see how this looks directly in PRTG.
That's what we're doing now. I'm back to sharing my screen. As you can see now, I already jumped to one of my systems, which is my Synology in this part. And this time, I not just went for the simple solution as we did with the Dell and the Lenovo, just have the bare minimum in there to show you the difference. But with this one, since it could be something like a standalone system, something you use as a very one-sided system of storage, for example, for a small location or for your main storage as well, but in a certain way, we've jumped into one of our Synologies here as a cluster setup, where I'm just looking at the cluster right now, and we build it up to the point where we are able to take a look at everything that's inside of it. Once again, we are always starting the same, just check for the bare availability, just have it available and everything is good for the first time. And then we're going for things like, for example, uptime information. A lot of the time we can see if the system is starting on a regular basis. This is still something that may impact the flow in working with something like a storage system, especially in a Synology system, which is an all-in-one box system where it should be restarted on the regular basis. So you can check how long was it up. Things like a CPU load, and it's standard overview over like the baseline via network interfaces, which are like the physical interfaces we have right here, where we can see how much is being used, how is it utilized in the system. And then we can jump into the system at all, like have a disk-free overview just for the disks that are already there. Jump into a specific disk, for example, here a Docker disk that we have in the system, so we can see what's the free space there. It's a pre-built sensor. It's an SNMP disk-free. That's standard SNMP disk-free we're using for a lot of the systems, where you just can have a quick overview with this. Same goes for memory, swap space, virtual and physical memories, where you can see how is the utilization of the whole system at that very point. For access, things like the SSL certificates can also be checked that are directly on the system. So we see if it's available, if it is a trusted certificate, or in this part, if it's a self-signed certificate that is but also in the system itself. Then we're going for things like, for example, active processes that are running on the system, especially for a Synology that has maybe more than just one use case. We can use this to just see how many processes are there, how much is going on in the background, what is in there. And up to the very point where we can then jump right back into the physical monitoring. Once again, we're getting the information about the physical plate. Is it available? Is it not available? Do we have a good coverage with the system? Don't we have a good coverage with the system? How much is being used and utilized at the very point? And we can see every single case or every single disk that's already in the system. And we've got a full-on set of system health overview. Once again, a pre-built sensor we have, a pre-built sensor type we're working with that gives you the overview if your system is good or if something has failed inside of the system. You can see the temperature, you can see load status, you can see a fan status. Everything that's in the system itself will be gathered up, will be displayed here, and will help you determine if this system, as it stands right there, is on its load limit or if it's working to define places. On top of this one, once again, we're talking also about logical disks. Logical disks are the next storage possibility when we're not just looking at physical disk, but once the volume or the storage pool itself to be monitored, we also can check those. We have, once again, a multitude of possibilities that are in there to see if every single status, from being available to just being expanding to creating a new volume, or even to a degrading volume that's no longer up to par, we can check every single status with this one sensor, which gives you, once again, the benefit of having everything under your control at that very point. And for the last ones, as you can see, the last sensors are more of a sensor type, which you can use to gather up the data of systems that is also included. For example, if we are running an FTP server on this one, that should be something, for example, for your video surveillance system that just deposits some of the pictures on your FTP server whenever something happens. We can also help with this one, as from the application side, we are able to check if the FTP is working, if the FTP is there, and if there are files available on the FTP server. So if we can see there's still transactions in this. Same goes for HTTP and from the data we have in there. And that's for the quick overview of Synology. Michael.
Alrighty, so I'm sharing again, and we look at our last vendor relevant slide. So let's have a look at cloud storage and devices that aren't natively supported. Examples are AWS S3 or Microsoft Azure, Google Drive for supported ones. Like, monitoring these environments is a bit different from traditional SAN and NAS systems because they rely on APIs mostly. With PRTG, you can use native sensors like Amazon CloudWatch or Azure Storage Account for the supported ones. For everything else, like new storage devices, niche vendors, or also custom setups, you can create custom SNMP or REST API sensors to fill the gap. This gives you full flexibility, monitor object storage, growth, and even costs of your cloud storage, check API health for custom endpoints, and detect slow or failed sync jobs. So all in the same dashboard you're using for your on-prem storage. Let's jump into the demo once again and see how cloud storage metrics working live with PRTG, and yeah, maybe also have a look at one custom sensor briefly. Marco.
That's what we're going to do at the later stage. So I've just picked AWS at this very point just to give you a quick overview, because we have it once again at a glance, but in this part. What we have in the system right now are like EC2 instances, we've got the alarm overview, and we've got access to the EBS systems. And if we're jumping into the ABS system, we're just using our own credentials for this one, which means this is our own AWS system. We're just connecting to it and gathering up the data we have in the EBS there that is available. So we can see things once again like the queue links, the read latency, the write latency, things like these that we want to see. And we can check for availability or for degradation or whatever that is in the system. The big benefit we have with cloud storage like Azure and AWS is we do not really have to check for any physical availabilities. We don't have to check for fan speeds. We don't have to check for anything in these regards, simply because of it's no longer our problem. We're using AWS and Azure just for this reason, that we don't have to have the physical software anywhere in the house. So no hardware, no nothing available to us. So we don't need to monitor it. So we're just focusing on things like these ones and focusing on EC2 instances or in Azure on the virtual machines themselves as a machine for the system. And as Michael already told you, there are certain things that we would like to extend on. One of those things is, for example, that there is also in most of the cases a possibility to check for storage behavior and storage things, not just from the storage side itself, but also from the outside, from, for example, the application that is there to behave. In our case, we're now working with the VMware, so we've got the vCenter, and we've got a sensor within the system itself that is called VMware Data Store, where we check from the side of the VMware overview if the storage we've attached to it is working to the extent that VMware is also happy with it. This is also a lot of information that just comes from this, and it adds on to the information you already have, because on the one side, you have the information that is just there from the hardware side of things. where you know your NetApp is running, your Synology is running, everything is in vital parameters. And now we've got a application that is set up on these proficiencies and can give you the information that, oh, for me, it's also okay. I can access this system and I can see what capacity is there, how much is provisioned, how much are uncommitted bytes. And for the last one, Michael already told you, if you're still missing things and want to jump in further, things like an SNMP custom sensor and so on, we've already covered those things like importing of MIPS, for example, in the very first of this series in the network webinar. Here we are just like to give you a quick hint at this very point that we are also supporting custom variants of these sensors in the REST department. For example, in this case, something rather out of the loop, a Dropbox sensor where we're just checking the Dropbox status, just to see if our Dropbox is available so we can see that the website is up, the API is up. And that's a full on-set configuration. So we are requesting something from the World Wide Web at that very point. We're grabbing ourselves the component status we want, and we're checking it for its status. That's how we're doing it, for example, at this case for Dropbox. With this one, it's right on time, Michael.
Thanks once again, Marco. And we are already a little bit over time, so I'm trying to speed up from here. We have 2 more slides from data to insight. So like how to turn raw matrix into actionable information. And that's quite easy with PRTG. We have dashboards and alerts, and there's where everything comes together in PRTG. So you can visualize all your storage systems in one place, quickly see capacity, performance, health, etc. across your environments. By combining multiple vendors into one unified view, you also eliminate tool hopping, gain consistent visibility, and alerting everywhere. And proactive thresholds help to notify everything before issues escalate. So for example, when utilization trends up, latency starts to increase. Finally, automated reporting lets you deliver regular summaries of storage growth and performance, and that in an automated way ensures that both your technical teams and your management stay informed. And now let's wrap it up. What we've seen today with PRTG, you can unify monitoring across all major storage vendors, Dell, HP, NetApp, Synology, QNAP, even cloud storage. We're using native sensors and templates, so you get immediate visibility into the metrics that really matters, like capacity, performance, and health. And more importantly, with dashboards, alerts, and reports, you're no longer reacting to problems, but you are preventing them. And that is how PRTG turns storage monitoring into something that truly saves your day. And with this, I hope the questions have been already answered in our from our other experts. And I give it back to you, Natalie.
Yes. So yeah, thank you so much for sticking around. We are running over time, and I can see some people have already left. But yeah, thank you for your questions. Hopefully the team, I think they have been answering them. You should have seen that. Anything we don't get to though, we will be sending out in an email, so we'll be following up. Nothing will be unanswered, but for live questions, we'll just put it on hold for now. But just something I did want to let you know is that there's a no Monitoring Matters series this year, so this is the last one of the year. But in December, so December 10th, please hold that date. The registration isn't open yet, but we will inform you as soon as it is. December 10th is the Inside PRTG webinar, where we'll be wrapping up all of what's happened in 2025 and looking into 2026. And seeing as it is the season for giving, we will be giving away some freebies to those of you who do attend that one. So make sure you mark that in the diary. And as I say, we will be sending an invite for that as well. And just the final side to say thank you. And please bear in mind, there is a survey at the end of this. So when you close out, you should see a survey pop up. We'd love your feedback there. It takes 2 minutes. So please give us your feedback, and thank you for the heart emojis. And I hope it was a useful session for everyone. Thank you to Marco, Michael, and everyone in the background helping. And wish you a very good year. We'll see you in the new year with this series. All right. Have a good day. Bye-bye. Thank you.